Alright, so a polygon is a closed plane shape, which just means it's two-dimensional with straight sides. And examples include triangles, quadrilaterals, pentagons, hexagons, octagons, and so on. Now, a regular polygon has all sides equal and all angles are equal. Otherwise, it's irregular. And here you can see a regular pentagon. All the sides are the same length. And if we measured each of the angles, they would all be the same. And you can see here the difference would be an irregular pentagon, meaning that the sides are not all the same length. And if you measure the angles, they're not going to all be the same either. Here we have some pictures of the different types of polygons, and we name the polygons based on the number of sides that they have. Of course, the ones that we are familiar with would be the triangle that has 3 sides and a square that has 4. Now, some of us may be familiar with a pentagon. Penta, the prefix penta, means 5. Hexagon means 6. I always remember the hex has an X in it, and so does the number 6. So hexa means 6. Heptagon is 7, and octagon is 8, and a lot of us remember octagon by an octopus, and that is an 8. Nonagon is 9, and that one's kind of easy. Nona, 9, N and an N, nona, 9. And a decagon, which is 10. If we know about a decade, which is 10 years, then a decagon is 10-sided shape. So that prefix deca means 10. And of course we're familiar with triangles, but we're going to take triangles a little bit further and talk about their angles, on their interior angles, and the lengths of their sides. So a right triangle means that one angle in the triangle is a 90-degree angle, and we always represent that with that little square. An acute triangle, if we think of an acute angle is less than 90 degrees. So an acute triangle, all angles are less than 90 degrees. An obtuse triangle is just like an obtuse angle, and it means it's more than 90. So an obtuse triangle means that one angle is greater than 90 degrees. So that's looking at our triangles based on their angles. But let's look at triangles based on the lengths of their sides. An equilateral triangle, if I look at the prefix of equilateral, equal meaning equal or all the same. So all sides are the same length. And of course we represent that with those little hash marks. And if we use the same number of hash marks on each side, then those are showing the sides that are the same. And in this case, they've all got one single hash mark. So that tells me that all sides are the same, or an equilateral triangle. An isosceles triangle. Isosceles means 2. So on an isosceles triangle, 2 of the sides are the same length. And you can see here they've represented that with a little hash mark on each side. They did not put one down here because we can tell easily that this side is much shorter than these two. And then my last triangle is a scalene. And in this case, no sides are the same length. So if we measured these, all 3 sides would have a different length. Two-dimensional figures are all around us in the world. Artists and architects design artwork and buildings and other structures, and they incorporate a variety of two-dimensional figures in their structures. And it's helpful to know the properties of the two-dimensional figures so that we can describe their work and other real-life objects. So I challenge you to pay attention to the things around you and see if you can't find some of these polygons. And I think you will see that many of their shapes are very familiar to us in the things that we use every day.